if you've ever done an alignment on a 10 scale car, you know how troublesome that can be when you're trying to coordinate those two little lines next to each other to figure out, what degree of camber, or if you're looking at your toe, trying to get that adjusted. So I created Laseris, a laser alignment system that measures both toe and camber at the same time, making it a little easier. So inside the box, you get a laser, you get a target, you get the washers, and you get 4 aluminum uprights and the wheel nuts necessary to run the system, and a reusable box. So, important things about these uprights. Now, one side is perfectly flat, and that flat side is always supposed to face the hex. And the indented side faces out toward the wheel nut. You'll also notice that they're keyed right up here. This is a key, and this helps to align both the laser and the target each time in the exact same place. So very simple. That's what those are. So your laser. The laser is a class 1 laser. Obviously, if you pointed at your eyes, you could actually cause injury. It is USB rechargeable. So inside there is a LiPo battery along with circuitry to control the charge and discharge. Very simple. It takes about 45 minutes to charge a battery, and it will last for right around 16 hours is what we've been seeing. Then you have a target. The target is a matte black background, and you have white dots in a grid pattern, and you actually have 2 grids, and this represents toe out, toe in. If this were the front of the car, this is the toe out, and this would be toe in, and if this were the front, that would make this toe out. So the thing that's you need to understand is that on the top of each column there are single dots up here, and they represent the whole numbers 1, 2, 3, and 4 degrees of toe out. And then of course you got the half degrees are the ones that don't have those. So if I were looking for 1 degree toe out, it would be anywhere in this column, and then all I would have to do is select the amount of camber. So obviously it's, once again, 1 is the whole dot, then a half, a whole, a half, a whole. So there are 3 degrees. So all I'd have to do is find the grid pattern that I'm looking for. Say if I'm looking for 1 degree toe out and 1 degree of camber, it's this dot right here, and that's all it is. Very, very simple to use. And these are 1 millimeter dots, and you'll notice that the laser, when we go to use it, it is a 1 millimeter projection onto this. So it's very easy, and what happens is the light becomes very intense when it hits the dot. So we're going to try to show you. I know sometimes this camera, it has a tendency to overemphasize how bright that laser is, but it just gets bright. But hopefully it's showing it as a pinpoint. I know that sometimes it doesn't show that though. All right. Then of course you've got 4 wheel nuts, and then these items. There are 2 spacers. There are 2 thin and 2 thick. And this is because as I was experimenting and trying each different type of car, we noticed that there was a difference between manufacturers, and something had to be done, and that is because every manufacturer uses something different. In this case, this manufacturer has a shoulder on this wheel, and it is right here. Well, it would stop the plate, the upright, from sitting flat against the hex. So small shoulder, use a small washer, And this, because these are machined flat, it now compensates for that distance. Obviously, you go to the rear, we've got a thick one, so therefore a thick washer. Very simple to know when to use them. Obviously, on 10 scale on-road, we don't use any of the washers. So let's go through seeing how to actually work this. So here we go, here's a car, and we're going to go ahead and put this together. So it's got thick shoulders on the rear. So we're going to go ahead, we're going to put those on. And we go ahead, add those. Put the wheel nuts on. And now on this car, it does not have shoulders on the front, so we can go directly to the hex. And it's easy to tell whether or not that will work. When you get ready to put them on, if the plates will sit flat against the hex, then clearly you do not need the spacer. So anyway, we've got it all set now. Next thing is I always, whenever I'm going to set up the front, make sure that I turn the car on. That way it stabilizes the steering. So here's what we're going to do. We're going to go ahead and adjust. So like I said before, they're keyed, they fit together. One thing I will tell you is that when these are new, they can be very stiff and harder to put on, but over prolonged use, they loosen up a little bit, and then it will be easier to put that together. So we just turn the laser on, and let's see, if we wanted to be 1 by 1 degree of toe out by 1.5 of camber, we're actually just a little bit off on the toe. So we'll go ahead and we'll make an adjustment, and that's going to put it the wrong way. Let's go back, and you'll see it brighten up when I hit the dot. And there. So there it is, we're right on the adjustment. Now what we do is just simply switch sides. And we just move the target, and we move the laser. Turn it on, take our projections, make our adjustments, and I will tell you, you always adjust whichever side the laser's on. Those are the links that you adjust. The other nice thing that I did to make it good for off-road was we built the uprights tall enough that it will clear most wings. We do know, unless you go in and you happen to have a tall set of gurneys, or you've raised the wing height from the standard amount, this will shoot over the top of it without a problem, and you can go ahead and take your measurements back there and make your adjustments to the rear. Very simple, easy to use, and it does work for on-road cars as well. So it is 10 scale on-road and off-road. Works fantastic. There are in development right now are adapters to allow it to run on an 8 scale. So 8 scale off-road and on-road, this will end up working for it too.